All right. It is Tuesday, and I wanted to try something new this morning. Usually after the gym, I come home and I'm just like completely drained of all my energy because I go really hard in the gym, and it really slows down my morning when I get home, and really don't have a ritual, post-gym ritual. So I think what I want to do is do like a morning planning session on stream where I just kind of get my head together what I want to accomplish for the day. So let's do that. Oh, did I not have my calendar open here? Huh. Oh, yeah, that's right. It's a calendar.proton.me. Is that it? No. Well, I need to sort out my calendar on this machine. But I guess for today we can do it with Task Warrior. So actually, no, I'll just do it in a markdown document on my desktop today. .txt, MD. And here, zoom in here. I'm going to send this stuff over to here. We can kill that. Cool. So I have at 9 a.m. I have a 9 to 9:15 meeting with telehealth provider. And then besides that, I don't think I have anything else going on today. Let me grab my phone real fast. Alright, yeah, nothing else on the calendar for me personally, so things I do want to accomplish though. So after this planning session, I need to shower, dress, breakfast. And then where we left off on the Linux programming interface was chapter 13. I actually did some reading on it off stream about how IO is buffered in glibc and in the kernel. So I just have maybe, let's see, 1, 2, 3, 4, 5, 6 more pages of reading and 5 exercises to do on that chapter. So we're going to stream on that, which is file IO buffering, and then file systems. Stream, reading, file IO, and file systems, plus exercises. And then lunch, which is going to be, oops. So we'll break for lunch. What do I got going on for lunch today? Chicken breast. Let's see. Eggs. So that's a lot of fat and protein. For carbs, probably like sourdough bread. That'll be my lunch. And after lunch, see what type of exercise they got here. So the file IO exercises, let's just review these, see how difficult they are. Using the time built-in command of the shell, Using time built-in command of the shell, try timing the operation of the program you're listening for on your system. Experiment with different file and buffer sizes. You can set the buffer size using the debuff size compile option when compiling the program. Modify the open system call to include osync flag. How much difference does this make to the speed of various buffer sizes? Try performing these timing tests on a range of file systems. Are the results similar? Are the trends the same when growing from small to large buffer sizes? Okay. Time the operation of file buff write bytes program provided in the source code distribution of this book for various buffer sizes. So the first exercise, the complexity there is getting different file system, because I think there's BTRFS on this machine, but I would have to create a new partition, format it, mount it for another file system. Or I could do it inside a QEMU sort of virtual machine, but that's gonna probably have some overhead, not related to just a file system. So probably the best thing for me to do would be to partition part of the disk, do some repartitioning, which it's been a while since I had to do that, but pretty confident I can do that. What's the effect? That's just a knowledge test. Explain why the output of the following code differs depending on whether standard output is redirected to a terminal or disk file. Command tail file prints the last name file. Implement this command using IO system calls. Keep in mind buffering issues described in this chapter in order to make the implementation efficient. So they do have one implementation exercise in this chapter, which is to implement tail-n, which is annoying. I don't like writing stuff that's already implemented. But I'll try to get that done. Maybe I'll use AI to help me with that one. So yeah, the exercises for chapter 13. File IO are not too bad. And if we look at file systems, the reading, seems pretty straightforward. Okay, lots of code here. There's only one exercise. Write a program that measures the time required to create and then remove a large number of 1-byte files from a single directory. The program should create files with the names of the form so-and-so, where so-and-so is replaced by a random 6-digit number. The file should be created in the random order in which the names are generated and then deleted in increasing numeric order. The number of files and the directory in which they are created should be specified in the command line. Measure the time required for different values NF for different file systems. So this is just testing performance of different file systems. What patterns do you observe in each file system as NF increases? How do the various file systems compare? Do the results change if the files are created in increasing numeric order and then deleted in the same order? So it's just basically probing file system behavior. But again, that's another coding thing. So it's gonna be probably tight trying to get it all done in the afternoon stream, but I think it's doable. And then we'll say dinner, beef, and then we'll do an evening stream. Okay, sounds like a pretty good plan for the day. I didn't drink any on the Matcha. Morning, Matcha stream. Okay. It's 7:30 here. Cool. That sounds like a game plan for the day. I'm gonna go ahead and wrap here and get started with my day here. And I'll be back on around 10 my time, mountain time. Cool. Alright, see you all then. Bye.